Yes, after having a long power cut, I continue the previous exercise here. So we have three groups in the given example. We have taken B and D. Now what we can do then, we get the group 2. So for group 2 we have A, B, C and D. Group 2, the first value is 1, 1, 1, 1. So we take it 1, 1, 1, 1. And the second value is here. It is 1, 1, 1, 0. 1, 1, 1, 0. So it is very clear. We can take A, B and C as common values. Then we say, oh, we cannot take D here. Now B and D O, A and B and C O. Another group we have got, this is group 3. So we take A and B and C and D. For the first cell we have 0, 0, 0, 1. 0, 0, 0, 1. And then for the second group 0, 1. For the second cell here 0, 1, 0, 1. So we say 0, 1, 0, 1. What we have a common value here, we have A bar. A as bar, so we say A bar. B is not common, but C bar is common. So A bar and C bar has come. Now we have to take the simplified version of the Boolean equation like this: B and D O, A and B and C O, A bar and C bar. If you try to get the same Boolean simplified answer by seeing the truth table here for the entire group, we can understand here B is common. See, B is common, and here we have a group like this. We have 4 cells. For all the cells, A is not common, but B is common, so B can be taken. From this side, C is not common, but D is common, so B and D has come from the first group. What about the second group here? A and B can be taken, A and B, for both 2, A and B. What about C? C is common, but D is not common. So A and B and C can be taken. And for the last one, say A bar, A bar, A bar, A bar, B bar and B. So A bar is common for the 2 cells. And here 0 and 1 is common for both cells. So it means C bar and D. So for this part, A bar and C bar and D, I have missed the D here. See, D is common. Yeah, I have taken it, but I have missed it. So then I can verify that statement, A bar and C bar and D. So try to actually understand the entire statement without having such mistakes. It is better to check it again and again. So after that, I can complete the entire statement. Right. Then this is okay. So I use both methods, even with the thing is A bar and C bar and D also. So D has come. So this is the way of simplifying Boolean expressions. Right. Not only this, uh, then after that, I would like to discuss some situations which can be more useful you to take idea about simplifying Boolean expressions using Kanu maps. Right. So I erase it. I take 4 variable or 2 variable, 3 variable K maps, but it is better to I have some examples to show you. Yeah, I take 3 variable. Three variable K map here. We have 2 rows and 4 columns. Then I say A and B and C. Now in a such a K map, suppose a situation like this. I would like to take a situation here. We have 1, 1, and again 1, 1, and 1, 1. So by seeing how I have filled this one, you can take a Boolean equation, that is the reverse order. But this time I want to show you what are the things you have to consider when grouping. I will try to group them. So there you take 4 cells here. We can make a group of 4 variables in this. I can see this one properly, so I have a group here. Then after that, what we are going to do? You can see there are 2 ones here. You can easily make a group, but don't do it very quickly, because you have to check whether there is an ability to create another 4 cells group. Here our rule says if you have cells from left corner and right corner, they can group left corner or the right corner, top or bottom. So there is a rule there. Left and right and top and bottom cells can be joined. So there you have a chance to make a group by joining these 2 and these 2. So what is the way of grouping them? You draw something like this to cover. You draw a curve here. This curve, 1, 2, 3, and 4. How many groups have we got? There are 2 groups. This is group 1, and this 4 can be taken as group 2. group 2. It is actually a group with 4 cells. Group with 4 cells. This is the way of grouping. Right. Then what you can do, you can practice, you can write the first Boolean equation here, then you can simplify it by using the 2 groups. There you want to take these 4 as a 1. So we want to check whether there is something to common for all these things. For example, here A bar and B bar, here A and B bar. So B bar is common. See, B bar is common for all the 4 cells in the group, but 0 is not common. 0 is for these 2. 1 is not common. 1 is for these 2. But we have something common, that is B bar. B is here, but B bar works. B bar, B bar. So this is the way of taking something out. It's a one example when you are thinking about 3 variables K-map. So if you have a chance to get, suppose you don't have, I would like to change it. I would like to change it. Suppose you don't have values here. Now we have change values like this, and suppose a situation like this. Now what you can do, you have 4 values like this. You can make a group here by joining these 2, and at the same time you can make another group by using these 2, and the third group can be created by using these 2 cells according to left and right. So these 2 can be joined together, and these 2 can be joined together. Because but there is a possibility of reducing. Now no need 3 groups here. You can reduce. I think it is better to understand. I remove it is better to change the structure, then I show you. Let's see, remove it. It can be a possible example. Suppose you have values like this. You have 1 here, and again 1 here, and like this. Now what you can do, you easily join this part, these 2. See. Here you can set up a group, but the thing is, there is a 1 here. You don't take it as a single group, so it is better to create another group. Now you have a 1 here, but according to left and right rules, we should take these 2. So then we join these 2, this 1 and this 1 also. See, we need 3 groups. I'm correct, early example. We need actually 3 groups here, because if you remove this one, and then actually you are unable to get this one, so then we need these 2. And even if there is a chance of removing the middle one, See, if I remove the middle one here, see what I can get. I remove that. We check the ability here. See, now what can we see? We have two groups only. Now we have a group here. All the ones have joined, and here the second group. So I could reduce one group here. This is a better example. If I got a third group here, what may happen? I actually have increased number of groups. So the second rule says try to set up at least number of groups. So according to this one, the above rule, it is better to actually group like this without going for a third group. Third group is not needed. Why? All the ones have added at least into one group here. So this is another example, right? Let's see. I would like to show you 4 variable schema again. So what you can do, you can practice with these things. Then I'm going to draw a 4 variable schema. We have 16 cells, and here I have A and B and C and D, and the values also. Right. Now I wanted to show you one particular example here. Suppose I have one here, another value, and another value. What about the situation? What I can do, I can take all the here I have a chance now. Left and right rule says a 1. But here again left and right. So with top and bottom, I can set up only one group. If I see such a situation, I go for a one group. See, go here, second, third, and fourth. There is only one group. So remember, you don't create two groups here. Instead, you are going to take a single group in order to simplify. So just try it and remember. And then again, in the teacher's guide, they have given some examples. You can read them. I will show. We can later on check them also. Then you can increase your knowledge of group in how to set up groups. I would like to show you another example. This time we have something like this. We have 1, 1, 1, 1, again 1, 1, 1, 1, 1, and 1. Here we have a different situation, how you can set up groups. Now, first thing is we want to think about a group with 8 cells. I see 1, 2, 3, 4, 5, 6, 7, 8. So I have a chance. Of grouping cells with 8. So then I take it as a one group. This is the first time we see a group with 8. It is okay. So then after that, what are the other possibilities? Here, now you have to be careful with the groups because now there are some situation here. See, one here, second one here, third one here, fourth one here. Yeah, can we take a 4 cells group? Yes, we have ability. So then we go for another group. See, first one, second one, third one, and fourth one. So after actually overlapping, there may be several lines. We cannot do something for it. But anyhow, now we have found 2 groups here. We have found 2 groups. So then what we are going to do, can we take this one as a single group? No. The thing is, there is no any other way. We cannot take these 2 as a group. If it is top and bottom or left and right only we can add. So we cannot take these 2. But here there are 2. What we can do, we make a group here with 2. Now there are 3 groups. We have a large group with 8 cells. Then we have a group with 4 cells according to top, bottom and left, right rules. And now there are 2 consecutive cells here. We have joined them. So this is the way of grouping 8. Right? So my aim is to introduce something like this. So then you can do here. You are going to write the Boolean expression and then grouping and simplifying it, right? So then it make more easy. I would like to show you another example with 4 variable K-map. Let's see, draw it another one. Now suppose you have a K-map like this. This time I would like to make a change, and I say the values are P, Q, R, S. So if you see different values in the exam, no problem. It can be 0, 0, 0, 1, 1, 1, and 1, 0. Similarly, 0, 0, 0, 1, 1, 1, and 1, 0. Now, how we have taken the values here. And third row we have 1, 1, here even 1, and again 1 here and 1 in this place. Now we want to make a group. Now suppose the situation, this is a very useful situation. We are going to create a larger group. So we try to get 4 cells, but we are unable. 2 cells is possible, 2 cells here. Now you can take 2 cells. Yes, so be very careful here. You have to try to reduce number of cells. Now if you draw something like this here, it should be the first one, then you need to get this one, second one, and you need to get the upper one, and so there may be 3 groups. But here there is a situation you have to think that you should take fewer groups, not more groups, right? So in K-maps, the most considerable thing is you are going to take groups as large as possible. That's the first rule. Second rule, you try to get least number of groups. So there you have a chance you get these two as a group and these two as a group. Then after that you can reduce number of groups up to 2. Why? At least a single one should have within a single group. So these two are now in a group. Here they are in a group. There is one. There is no chance to join them. So we take this one as a single group. This is a single group. Now how many groups are there? There are 3. There are 3 groups. So I think with these examples you will be able to make groups first. Then simplification is easy, right? Everybody can do the simplification. The only thing is grouping like this, right? If you group these things, then you actually you may familiar with solving problems. This is not the end of K-maps or Boolean simplifications. We have to continue because we have to improve our knowledge. If you are thinking about getting a pass at the exam, so you need to find out more and practice more. Then you have actually a chance to get more marks from the part B logic gate question, and there may be several questions in paper 1 also. Right. Now I want to do another K-map with you. Let's just see here. I have a Boolean expression. I would like to take it. This expression says Z equal. This expression, the first thing is Boolean expressions. A bar and B and C bar. It says A bar and B and C bar. O A and B and C. Again it says A and B and C. O A and B and C bar. A and B and C bar. O A and B and C. A and B and C. Now we have Boolean expressions with 3 variables. Okay, I need to verify it. A bar and B and C bar, A and B and C. No, A and B bar and C, B bar and C, and A and B and C bar, it's okay, A and B and C, right. Now I have 3 variables, so K-map would be like this. So I take 1, 2, 3 and 4. A and B comes here and C here. So we have A and B 0, 0, 0, 1 and 1, 1, 1, 0. C can be 0, 1. What is the thing? We get it 0, 1, 0. 1, 0, 1. 1, 1, 0, 1, 1, 1. It is very easy. 0, 1, 0. So we have 0, 1, 0 here. 1, 0, 1. 1, 0 and 1. It is here. 1, 1, 0. We have 1, 1 and 0 here. 1, 1, 1. 1, 1 and 1. Now this is the way. So then you have to think about grouping them. Right. So according to the rules, we are unable to take 4. But here, now, if you create a group here, then you need 3 groups. Once you see such a situation, again check whether you can reduce the number of groups, because try to create fewer number of groups. What may happen if you create a group here, these 2 ones have joined into a group, so then you can go for a second. No need of grouping this part, because at least one has got a 1 group. So then the second rule has come here even. Right. Then what you can do, it is easy. Now steps can be used, or you can use the rules. Now here 0 means A bar and A for this group, A bar and A. But here B is here, and here the B is common. And what about C bar? C bar is common. So B and C bar. B and C bar. Or for the second group here, A is common. A. B bar. A is common. So we can take A. And what about C here? C is common for these 2. So, and as the output we can take B. We have a chance to take B and C bar and A and C. B and C bar or A and C without writing the groups and the values. So if you try to write the values, you get the same. What we have 2 groups. So take this one as group 1 and take this one as group 2. I would like to take group 1. I have A, B and C. First cell says 0, 1, 0. So 0, 1, 0. Second one says 1, 1, 0, 1, 1, 0. Now from here, what is common? B and C bar. So it takes the same B and C bar. Now we have the second group here. We have A and B and C. What are the values? We have got 1, 1, 1, 1, 1, 1 for the first cell, 1, 1, 1. Second one, 1, 0, 1, 1, 0, 1. Then A is common and C is common. So we say A and C bar. The same answer, both are correct. I get it by seeing the K-map here, or even by using the values, by writing the values in each group, I could get the same answer. So you can continue such exercises. This time, before completing the lesson, I would like to discuss another example. Then after that, you have a chance to do all the exam questions, all the previous questions. Actually, we have actually introduced and discussed so many things with the teacher's guide and other things. So then you can continue your knowledge for writing answers for all the K-maps questions and Boolean simplifications. Anyhow, we see the next one. I have a Boolean expression, but I have selected this one. It would be like this. It says Z equal A O B O C bar and A O B bar O C bar, and continues and A O B O C, A O B O C and A bar O B O C. This is the given expression. In the teacher's guide, we haven't seen such expressions for simplifications. Now you can understand this is a product of sum statement. This is a POS statement. Then what we can do, because we have learned how to simplify all the sum of product expressions. Now, as you know, the K map and idea of the sum of product expression is, if you use this statement, these four opportunities have got outcomes. So if you have these four, then you can get the output. By thinking that, you can input these values into a variable, into the K map. You have to check the variables. There are three. So as there are three variables, we are going to draw three variable K map. Now here we have Kanu map with three variables. We have A and B, here C. What I want to do, I'll say 0, 0, 0, 1, 1, 1, 1, 0. C can be 0 or 1. Suppose we haven't done anything, but in an exam, or especially in an exam, you may see you haven't expected such a thing. This is the model in the exam paper. Unexpected questions can be seen. The expression is POS. But you know, if you have a POS statement, you know how to convert it into a SOP. But this time, they don't ask you to convert it into a SOP, they ask you to simplify it. If you go for Boolean rules, I would like to say something. We did not simplify any POS statement yet, because in the syllabus or the teacher's guide, they haven't shown simplifications of POS statement. But what we can do, we can apply the same rules. If you have such a statement, you are actually try to pair. You try to pair them. So after pairing, if there aren't enough statements, you can get the statement by using the same rule, A equal A. But here there are four, then there is a compatibility. But we didn't do them. Now I try to do something. I know how to write the values. There is no harm here. It should be 1, 1, 0. Again 1, 0, 0. Now I have 1, 1, 1. Again 0, 1, 1. Now I try to fill it. 1, 1, 0. 1, 1, 0 is here. 1. 1 0 0 1 0 0, it is here. 1 1 1, we have 1 1 1, and 0 1 1, we have 0 1 and again 1. Now this is how I see the values. Then I am going to group it. How can I go for 3 groups by doing this one and second one and third one? No. Now you know definitely the method is creating larger groups and then actually try to create minimum number of groups. So one particular single one should be within at least one group. So what you can do, you can think about such situations. So you group these two and then you group these two. So, this is the way. So after doing these two, then what you can do by seeing, now you try to get common values here. What are the common values? Here we have two groups. So we take group 1, and here group 2. So I try to find out common value. A is common, but B here and B bar. So A is common, I take A. But remember the type of the statement is POS. So with A, I have to take as O. What about this one? 0. 0 is common. It is C bar. So I say AOC bar. AOC bar. And what about the second group? Second group I have A and here A bar and here A. That is not common, but B is common. See B is common. So I say B. O. There is something common there. We have common C. C is common for both cells here, B or C. So finally we have taken AOC bar and BOC. I have abbreviated like this. Now if I go for the values here, what we have A and B and C. For the group 1 cell 1, 1 1 0, we have 1 1 0 here. Then 1 0 0, 1 0 0. What are the common things? We have common A, C. But what is the way? This is a product of sum statement. So we say A, O, C. If it is a sum of product statement, we say A and C. But here we say A, O, C, and. And for the second group, I come to second group. Maybe C. What about value? 0, 1, 1. So we say 0, 1, 1 here. For the second one, 1, 1, 1. 1, 1, 1. Now it is very clear I am unable to take A, but I can take B. So I say B. B, it should be O because of POS. Then C. C is possible. Right. Then I see the correct answer. So I verified it. I can use one method of two methods here. This is the way of actually simplifying a POS statement. Now you have idea about solving such problems. Now if you like to simplify this by using Boolean rules, then how you can do? You have to think about the pairs. So when you think about the pairs, you may understand there are some similar situations. See, these two, BOC is common. So you can remove AO, A bar here. And here even AOC bar, AOC bar, AOC bar is common. So you can remove BO, B bar. So after pairing, you have to use all the rules. What are the rules? Distributive law, redundancy law, and De Morgan. We don't need to use De Morgan here. Now with some basic Boolean rules, you can actually simplify the POS statement also. But don't worry of doing such a things. This is enough. So after a long way, you have to ready for the exam. So once you are ready for the exam, you can do such practices. But here, I think it is enough. But later on, you can, if you prefer, you can try resolving these things. But this is enough. We have discussed so many things. Later on, we will continue some exercises of simplifying such things. Okay, so I think you may have taken a proper idea about simplifying K-maps, simplifying using K-maps, and the simplifying Boolean equations using Boolean rules also. Right. So let's stop the lesson here.